Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. Today's episode is one of several in our series on the mobile and off-highway equipment market. There's a real drive underway today to improve machine safety, machine performance, and machine capability. The driving force behind this movement is, of course, technological advancement. New technology makes new things possible, but advancements in technology can be a two-edged sword. As machine builders or operators look to incorporate new technology into their machines, all technology is not the same. It requires a deep understanding to wade through the specifications of something as important as radio communication. Can they find a partner that understands the technical benefits without ignoring the drawbacks or limitations? When control of the equipment is dependent upon radio communication, the wrong choice can have big consequences. Here to help us work through some specifics of radio communication is Mr. Fritz Jaessing. He is an account manager for Morrell's newest subsidiary, LOR Mobile Controls. Fritz, thank you for joining us.
Well, thanks for having me, Tim.
Let's start with you telling us a little bit about LOR.
Sure. So LOR Mobile Controls is based in Central Michigan, and we engineer and manufacture control equipment for our OEM off-highway clients. Control equipment would be things like radio remote controls, machine start panels, displays for CAN bus control type items, maybe wiring harnesses and power distribution kits for diesel engines, things of that nature.
Okay. Well, tell us a little bit about the radio control. What devices make up that system?
Sure. So if a customer needs a radio control kit, you'll have a transmitter that is the part you hold in your hand and has all of the joysticks or toggle switches or push buttons to run the functions on the machine.
That's the transmitter.
That's a transmitter that you hold in your hand. And in that transmitter, with all the circuitry, is going to be a little modem, and that modem is sending that signal wirelessly to the machine, where it's received by our receiver. Okay. So that would be the part that's mounted on your machine. And from the receiver, you will run a wiring harness out of that to all of the, I'm going to say, functions on your machine so that you can control it.
The devices, the valves, the
That's
motors,
correct. Yes.
Whatever.
Yep. And so in order to continue to improve that signal strength, then you would also run maybe an antenna cable or two off of the receiver, mount those antennas up somewhere high on your machine, because of course most of the off-highway industrial equipment is rather large, and of course large chunks of metal getting in the way of line of sight communication is never a good thing. So you'll have signals going from the transmitter to the antennas down to the receivers. In some cases, especially on CAN bus controlled equipment, you might have signals coming back to the transmitter. That might be like engine information, for example. If you want to look at your transmitter and on a little display see RPMs or see oil pressures or fuel usage, things like that, we can send that information both ways.
So it's bi-directional information flow.
It certainly can be, yes.
So the piece of equipment, it not only has a receiver, but it has a transmitter as well?
Well, I don't want to confuse the topic on that one. We want to make sure that there is two-way communication.
Okay.
But the transmitter is the part you hold in your hand.
That's what I hold in my hand.
There you go. And the receiver will mount to the machine.
So a customer comes in, whether it's a machine builder or machine owner / operator, they want to install radio controls on their machine. What does the conversation look like?
Sure. So the good thing is although we have some standardized product designs, I'm going to say enclosure designs for radios, maybe a single handheld, two handheld, medium sized, and then a belly box. They can come in, and if they tell us what the application is, because that's always the first question, what are you working on? Are you working on a little stump grinder? Are you working on a big piece of ag equipment? Are you working on a backhoe? What are you doing? Once they tell us what the application is, we can fit them into a product line that works the best for their operator, right? So if you have, for example, a machine that they expect to drive, maybe it's got tracks or wheels, they're going to drive it off-road, you don't want to have a little single handheld that's got push buttons on it because your thumbs will fry by the time that machine goes 2 miles an hour, 100 yards across the field or whatever it might be. So then you'd put them into a different design that has joysticks maybe. So that's the kind of considerations we'd have when we start the design process. Because again, although there's the enclosure that looks similar, we're designing these from scratch. They may look the same, yours may look the same as somebody else's, but the software programming inside and the interfunctionality between switches is all going to be custom to whatever your specifications are. So once we figure out what the application is, then the next thing I need to know is I need to know where are you going to use it? Where are you selling it? Where are you going to operate it?
Why does that matter?
Yeah, you wouldn't think it would, right? You'd think that you just give them the product and let them go crazy with it. But governments around the world have seen fit to regulate frequency usage. And so, although there's a variety of frequencies we can use in our shop, primarily 900 megahertz and 2.4 gigahertz is somewhat industry standard for off-highway equipment.
So in other countries, it's an FCC type issue.
Yes, well, FCC being in the U.S., correct?
US.
Yep. We are, I'm going to call us lesser regulated. So 900 megahertz, a much stronger band that has more signal strength, more reliability, things like that. We can use that in the U.S. It's no problem. We can also use 2.4 gigahertz, but the kicker is that 2.4 gigahertz sometimes has a little less range, little less signal reliability because it doesn't quite bend around objects as well. So if you're in a loader, for example, it might not, if you got a metal obstruction or something like that, it might cause problems.
Is that 2.4 like the Wi-Fi router that I have at home, 2.4
Oh,
gigahertz?
yeah, absolutely. It is the same. And so there are interference concerns like that we have to be cognizant of. But the good news about 2.4 gigahertz is that it is worldwide accepted. So as long as it's a 2.4 gigahertz low power modem, you can use it around the world. So there's considerations for businesses when you think about which way are we going to go? Are we going to only be in the US? Are we going to sell around the world? Do we want to deal with and engineer and control two different radio setups, a 900 and a 2.4, depending on what that machine's doing? Those are all considerations for people.
So you sell both systems, a 900 and a 2.4.
Yes, and many times for the same machine. That's how it's been historically, because maybe a machine would start out and they'll say, "Oh yeah, we're just doing it in the United States." Okay, great. We would rather use 900. We know it's a stronger signal, more reliable, which is ultimately the goal, a reliable signal. But then at some point, maybe they start to say, "Oh, well, now we've branched out and we're going to start selling them overseas. Now we have to make an identical system with different modems on it." And yes, in theory, they're interchangeable, but if a operator with a 900 megahertz radio kit on a machine runs over the transmitter, he can't just get another 900 megahertz radio. I mean, he'd have to get the same band, if you understand what I'm saying.
Yeah.
So that's just consideration. And so one of the things that we've done at LOR Mobile is we have designed a proprietary modem called the FEX that is 2.4 gigahertz, but it gets the same range or very close and the same signal reliability as 900 because it's got this great little RF switch buried inside of the circuitry where we can use dual antennas, and that modem will take signals from both antennas and decide which one's stronger and will hang on to that signal. Most of the other 2.4 modems on the market don't do that. They've got a single antenna input. So if that signal bounces off something out in the world and then comes back and misses your antenna or gets blocked some way, that's going to be a hiccup signal, and it's not going to be quite as reliable.
So signal strength, acceptability, the range. Is there a range difference between the 900 and the 2.4?
Yes. So a 900 megahertz signal on an off-highway piece of equipment will go pretty typically about 1,500 feet without anything extra, right? A 2.4, you might be looking at more like 1,000 feet or something like that. So there is a decrease. Now, keep in mind, we're dealing with off-highway equipment that can hurt somebody. How far away do you realistically need to get? But what I would argue is that if you get the strongest range possible, or the 1,500 feet, if you get obstructions in the way, maybe that'll go down to 1,000 then. If 2.4 only goes to 1,000, then you might only get 500. The point being is that the range is different between the two, but with the FEX, we're darn close. So if 900 is 1,500 feet, this one would be 1,300, 1,200, something like that. So we're pretty close.
Is there a cost implication? One, the higher frequency is more expensive than the lower frequency?
No, there wouldn't be on the engineering or manufacturing side. The modems are going to be roughly the same price overall. Yeah, that would not be a consideration.
So the business case for the machine operator or the equipment builder, the business case is selecting one frequency over another or using dual frequencies?
Well, what we tend to think about is how much product do you want to control and how many designs do you want to deal with for one machine. So if the 2.4 FEX modem can do just about as much as the 900 megahertz, right? And then you only need one radio kit for one machine to sell all around the world, and it works great everywhere. Why not do that?
Are they field retrofittable? So if somebody had 900 megahertz out there, can they upgrade it to 2.4? Is that possible? Or
Yeah, it's not so much of an upgrade. That would be to swap out the transmitter and the receiver and put new ones in there, because it's all the circuit board mounted technology. The modem, for example.
Okay.
So yeah, that wouldn't be the ideal. The ideal would be to pick the one you want, or you're going to go forward with one radio kit. And so that would be our discussion. Hopefully, we can identify that in the design phase early on in the engineering before we get down to production.
Okay. Well, on evolution and controls, we like to talk about technology, and not just technology, but the change in technology and the pace of change in technology. You guys are designing and building these pieces of equipment. Are you concerned about the next generation? Or is this the end? Is there more in sight?
Well, it's hard to tell what any government is going to do to regulate future frequency use. So those would be considerations. But I think our goal at LOR Mobile is really signal reliability. When you're talking about a primary need of a radio remote control, it's signal reliability. Because once that signal falters, now you've got no more control, and nobody needs that.
It's like when the Wi-Fi drops at home. I have no internet.
That's right. Yep. So that's the deal. When you're out, when you're out working on these job sites or safety considerations or whatever, when we think about growing, we think about what is the next steps we can take to make a more reliable signal into our radio kits.
Over the next 5 years, or looking 5 years down the road, do you expect any change in the adoption of this technology?
Well, I think that as signal reliability becomes more prominent in the industry, I mean, it's really good right now, but there's still quite a few people from old school that still like the mechanical valves, because there is no messing with a mechanical valve. But as the signal reliability becomes stronger and as the distance gets greater, more and more people, I'm sure, are going to continue to come over to the radio-controlled side, if you will. Because it really is, as far as safety and functionality and flexibility, radio remotes are really where it's at. And that's, I think, the future of the industry.
That's fascinating. Fritz, thank you so much for joining us. I appreciate your time.
Thanks for having me, Tim.
To learn more about LOR and their systems and solutions for the mobile and off-highway market, visit lormobilecontrols.com. To learn more about Morrell and their systems and solutions, visit morrell-group.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version, so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.